Section 4.6, 3 by 3 Matrices, Determinants, and Inverses. In this section, we're going to explore the determinants and inverses of 3 by 3 matrices like we did in the previous section with 2 by 2 matrices. However, in this section, we are also going to be using our graphing calculator to help us with some of these matrices. So, what I want to do here is start with the determinant of the 3 by 3 matrix, which has this fairly lengthy formula with a lot of subscripts thanks to my matrix here. And so what I want to do is not so much focus on memorizing the formula, which you obviously can, but is fairly daunting. What I like to do with a 3 by 3 matrix is think of it visually as actually following along the diagonals. If you remember from a 2 by 2 matrix, we simply did a diagonal one way, we multiplied all those elements together, and then we did the diagonal the other way, the opposite direction, and multiplied those together, and subtracted our two results. Well, we're kind of going to do the same thing with this. So what this formula does is it takes me, first of all, diagonally down the main diagonal, and I multiply those three together like this. Then I just continue with my diagonals, remembering that I have to keep 3 numbers in each one. So it doesn't matter which side you want to go on here next, because we're going to add these all together anyway. So then I multiply next these two, but since I need a third one, I'm going to swing around up here to the opposite side. I'm going to pick up my third one over here, this C here. Then I'm going to do the same thing with the last diagonal that I have here, picking up this third element over here on this side. So everything's going to go diagonally that direction. Then when I do the other side, which is all these over here in my second set of parentheses, I go the opposite direction. So I'm going to go down the main diagonal the opposite way. And then again, I'm going to do another diagonal, come around, pick up my third number there, and then do the last diagonal and pick up my third number over here. So I just basically do the diagonals in both directions again, add all those results together on each side, and then subtract the two from each other. So let's take a look at how we would actually do one of those with the formula. Okay, so here is my matrix, and I'm going to find my determinant, and I'm going to start out again by going along the main diagonal. So what I want to do is take down the main diagonal, 0 times 2 times 1. Okay, well 0 times 2 times 1 is just simply going to give me a 0. So I'm going to write down a 0. Now I'm going to take care of my other diagonals going the same direction. So I have 0, 1, and I'm going to come over here and pick up -3. So 1 times 0 and -3 also make 0. And then the last diagonal, 2 and 4, and a -2. So 2 times 4 is 8. 8 times -2 is actually going to make this a -16. Okay, so there is my values from my first direction of my diagonals. Now I'm going to swap this. Okay, so let me erase this because we're going to go the opposite direction. Okay, and I highly encourage you to write out your matrix and draw on it like I am here, so it sort of kind of makes sense to you. So then now I'm going to do my diagonals going the opposite way. So I'm going to go the opposite direction this time, doing -3 times 2 times -2. Okay, so now remember in between here is going to be subtraction. So the second group here is -3 times 2 times -2. That's going to give me a positive 12. Continue with my diagonals in that direction. I get 4 times 0, which is going to give me 0. And then I'm going to get 1 times 2. Come around and pick up the third number is still going to be 2. Okay, so let's finish this up with our math here. -16 minus, over in my right-hand parentheses, I'm going to get 14, and -16 minus 14 is going to give me a determinant of -30. Now, if you remember from the last section, determinants do two things. They determine whether or not this matrix would even have a inverse, and this one would because the determinant is not 0. And then also, they play a role in calculating the determinant. Now, for the 3 by 3 matrices, I am not going to show you the formula for calculating 3 by 3 inverses. you can definitely do that without the graphing calculator, but we're going to check ours using the graphing calculator. Okay, so what I'm going to do, get out of this for a second, and we are going to simply open up our graphing calculator here. So we're going to switch this, get my graphing calculator. All right, so if you remember, we're going to enter our matrices. So we're going to go into the matrix menu here. And to enter the matrices, we have to go over to Edit. Now, my particular matrix is a 3 by 3 matrix. So I'll go ahead and enter that as matrix A. It is 3 by 3, and the numbers I have here would be 0, 2, -3, 1, 2, 4, -2, 0, and 1. Okay, so there's my matrix, and I'm actually going to go back here and to my matrices, and this time I'm going to go over to the math menu first. And remember, in the math menu you find the determinant option, so we're going to do the determinant, and now I need to tell it which matrix to find the determinant of. So I'm going to find the determinant of A, so I'll enter my A there, close my parentheses up, and it tells me that my determinant is -30, which is definitely what I calculated. So we have calculated our determinant correctly here. All right, so another thing that I would use my graphing calculator for is verifying my inverses. If you remember from the last section, to verify an inverse, you have to verify that not only when you multiply A times B do you get the inverse, or sorry, the identity matrix, but also that it happens when you do B times A. And if you recall how we multiply matrices by doing rows times columns, when you start getting 3 by 3, 4 by 4, bigger matrices, just a lot more time consuming. So we're going to use our graphing calculator again for that. So let's go back to that just for a minute here. Switch my programs back to my graphing calculator. Okay, so clear this out of here. We'll go back into the matrix menu. Oops. Back over to edit. We can edit right over the top of matrix 1. Okay, so we do still have a 3 by 3 matrix. We just need to enter some new elements here. So since I'm going to verify these two, I'm going to put in 1, 5, -1, 1, 0, -1, and 1, 0, 0. And then, since I need another matrix, matrix B this time, which is a 3 by 3 as well, this one is 0, 0, 1, 0.2, -0.2, 0, 0, -1, and 1. Okay, so what I'm going to do is I'm simply going to tell my calculator then to multiply matrix A times matrix B, and you'll see that I get the identity matrix when I multiply A times B. So far so good. Let's just double check. So we'll do matrix B this time times matrix A. Okay, because we all know from past experience that just because you can multiply them one direction doesn't mean you can the other. And when I do B times A, I also get the inverse. So I have verified that these are inverses of one another. So I would definitely say that A times B and B times A both equal the identity matrix. So they are definitely inverses of each other. And that's all it takes to verify that those are inverses. Okay, the last thing we want to do here is similar to what we did in the last section, talking about solving a matrix equation. Very simple now that we know how these operate. Even though we can't use division on these, we'll use the inverse of the matrix to solve. And if you recall from the last section, what we do is we basically make a generic type of equation where we set up matrix A times matrix X equals matrix B. Okay, well, it's a multiplication problem, and to solve multiplication in matrices, we have to use the inverse. So what I'm going to end up doing is multiplying both sides of my equation by the inverse of A. Okay, and it's important that that A inverse be first because we want my A inverse and my A together like this. Since multiplication is not commutative in matrices, I need those two together on this side, which means I also need to put it that way on the right-hand side. Now, A inverse times A, those two are going to multiply together to be the identity, and the identity times X is just going to be X. So I end up with X is equal to the inverse of A times B. Well, then from here, I'm just going to use my graphing calculator. I'm simply going to label this matrix A and this matrix B, and I'm going to use some substitution and my graphing calculator to figure this out. So I will put matrix A in for A and B in for B, and we'll solve this with our graphing calculator. Okay, so let's go ahead and open our graphing calculator back up here again. Go back to our matrices. Back over to edit. Again, I'm just going to edit right over the top of matrix A again, just to keep everything in the same letters. So 0, 0, 2, 1, 3, negative 2, 1, negative 2, 1. It's that matrix there. Go back over to edit. Matrix 2 is in this case, is going to be a 3 by 1. So a little bit different matrix this time. And those numbers would be 6, negative 11, and 8. Okay, so now that I have those entered, let me clear that out. We're going to tell the calculator that we want to take the inverse of matrix A, so we put in A and then we tell it to do the inverse, times matrix B. And I see that matrix X should be equal to the matrix 1, negative 2, 3. So with that in mind, I just come back here and we're going to say that we solved this matrix equation, and our matrix was 1, negative 2, 3. And my equation is solved.